This is the 7th video in the 12-lesson series and marks a critical inflection point in the book of the same title, 12 Profound Lessons from Superstition. The material itself is easy to understand, but the inflection point is preposterous. At its heart is an unwinnable game, Bell's theorem. Bell's theorem is the most profound discovery of science, says physicist Henry Stapp from the Lawrence Berkeley National Laboratory of California. So let's go with a demo of Bell's game. Here's the playing board. The columns A, B and C allow the player to class the dice. Big or not big, white or not white, even or not even. So let's pick a few. Here is a big, white, not even dice. Here's a not big, not white, a not even dice. This one is a big, white and even one at the bottom. Big, not white and not even. Completing the list of this chart gives us a full complement to analyse Bell's Unwinnable Game. Taken 3 at a time, binary variables are complete if we have a list of 8. 2 to the 3 is 8. So if we can find another variable here, we'll win the Nobel Prize because there isn't one. Now Bell's theorem, or Bell's equation, looks like this. A, not B, is always less than or equal to A, not C, plus B, not C, with the bars on the top of all of these representing not. Now, the trick is that we've got 2 variables here and 3 in the table. So the rule is, if it's not in Bell's equation, we'll leave it off. For example, if we've got on the second row here, we've got A not B, we could make from those 2. And we've also got, and they appear on Bell's equation, we've also got A not C. On the second one, we've got B not C, which appears on the equation. This one we've got A not C, and we've also got B not C. Now down here, all we've got as the last one is A not B. That's all we can take out of that. The rest of them don't matter. Now, the next thing is just to add them up and write them under the equation here. So if we look over here, we've got 2 ABs. We've got 2 ACs and we've got 2 BCs. So 2 is less than or equal to 4. Now, that's very easy, and it's done. We showed an example, a demonstration of the use of Bell's equation. And it's easy and it looks trivial. But the thing is, this is never defied. If we pick dogs and cats, humans and non-humans, sheep and goats, buttons and dice. For example, there's no way that we can defy this equation. The magic is that when it's applied to trillions of subatomic particles, it defies it every time, 100%. To produce the trillions of subatomic particles required, we can use a laser like this one. This laser produces 7.8 thousand trillion particles per second. So here's our particles, photons. All light is like water waves, but laser light has the peculiar property of being like a cross-section, and that cross-section can be rotated through 360 degrees. This is used to great advantage in Polaroid sunglasses that stop reflected light, which is also polarized. It works like this. If we have a vertically polarized screen, vertically polarized light will pass through. But if the second screen is horizontally polarized, it'll be blocked. What we have here is a drill with a laser in its chuck. When we turn the drill on, the laser will rotate. Here is a polarized screen. Both the laser and the screen are polarized. So when the drill rotates, we'll expect to see the screen behind the polarizer get brighter and darker. So here's two screens. So the effect will be bright, dark, bright, dark. Now we have the A's, B's and C's of Bell's theorem. Photons instead of dice. The next step is to look at this miraculous Icelandic crystal, which creates two images instead of one. Unlike other materials, it has two refractive indices. So have a look at this water and we'll see one refractive index. To examine the crystal and its refractive indices now, we'll have a look at this text on the paper in front of me. So there you go, two clear images on the text. The next step is to put it all together. So here's the whole setup. Up the top we've got a laser, and down here we've got our calcite crystal that splits the beam from the laser to these two Polaroids. Behind the Polaroids there's a photodetector, and that feeds into a computer which is acting as a coincidence detector. So if it's a 0-0, it's a coincidence. If it's a 1-1, it's a coincidence. If it's a 1-0 or a 1-1, it's not. Bell's theorem becomes, in terms of photons and Polaroids, positive 30, negative 30 is always less than positive 30, 0, plus 0, negative 30. This never happens. Bell's theorem is always defied. Photons seem to want to go wherever they like, just to defy John Stewart Bell. Now obviously this has caused some high-level head scratching. And so far, one of three culprits, or all of three culprits, can be to blame. The photon twisting in Bell's theorem is akin to a large white 3 dice morphing in to a small red 6. It doesn't happen. One of three things could be wrong. Our view of reality, our view that there's an upper speed of light, or our logic, the same one as used by AI. Throughout history, the view of reality has been challenged many times, beginning with Plato, who wrote in the Republic that reality was no more real than the shadow of dwellers in a cave, the shadow on the wall of dwellers in a cave. Descartes reversed the idea that I am, therefore I think, to I think, therefore I am. In other words, I think, therefore there's an I, and everything that goes with it, like a reality that goes with it. Bishop Berkeley of Cloyne argued against Isaac Newton that there's no a priori existence, nothing out there at all. He wrote in his Principles of Knowledge that reality is a manifestation completely of the mind. This reverses the view of superstition altogether. If what's out there is not there, is not real, then we're superstitious. In the words of a very famous Buddhist Lama, Lama Thubten Yeshe, he wrote that appearances are nothing but the manifestations of our ordinary consciousness. They are merely apprehended or labelled by our superstitious mind. However, our basic problem is not that things appear to be self-existent, but that we believe it. The ultimate aim of every Tibetan Buddhist is to realise the state of superstition and get past that and realise the emptiness of inherent existence and the bliss associated with that. John Stewart Bell has gone a fair way to push that idea forward.